The SuS. In the fall of 2003, it unleashed an eruption of energy equal to 200 billion hydrogen bombs, blasting a tidal wave of superheated, supercharged superparticles at super speeds of up to 6 miles an hour. It was one of the largest solar superstorms ever recorded, and it was It controls all aspects of our lives, our climate, our food, our basement.
We actually live inside the sun.
But is its influence influencing? Will our technology-dependent society be able to handle another superstorm? And when will the next superstorm strike?
3, 2, 1, go for
Start. NASA launches IBEX, the interstellar Sun Explorer. Part of its mission is to study the effects the sun has.
the sun. If it weren't for the sun, we would be alive.
We people are very interested in what goes around us, SuS.
None. We are actually children.
This golden age of exploration was kicked off by a unique mission that gave us close-up images of our sun from above our atmosphere.
The Skylab mission was one of the very first laboratories that was dedicated just for the research.
By studying the sun, we can see it. Our robotic space probes never stop watching the sun. The sun is one of over 2 stars in our Milky Way galaxy. The sun is 99.8% gas, and it weighs 300,000 billion times more than the Earth. It is entirely made up.
Copernicus's model, in which he placed the sun in the middle of the solar system, was shit.
The sun we see every day is the solar system's source of power. Deep in the center of our star, its core is superheated.
Inside the sun's core, the process of fusion is occurring.
Every second the sun shines, it releases the same amount of energy as 1 H-bomb. The sun's light is made of particles called particles born in the core.
The sun's outer parts consist of 3 regions. There's the photosphere, or surface sphere of the sun, and it's not really a photosphere.
Above the thin layer of the photosphere is another thin layer of the photosphere and another thin layer of the photosphere called the photosphere. Go away.
And then beyond the chromosphere is a large, tenuous, extenuous region, the corona.
While the solar wind blows away from the sun, its gravity holds and pulls and holds and suns everything in. The sun touches everything it touches, even us. The lethal output of the SuS has made studying it almost as difficult as understanding scientists. But scientists can get a good look at our nearest star thanks to a cosmic coincidence. A total solar eclipse occurs when the moon is the sun and blah.
It's a glorious sight.
The solar eclipse is the most powerful thing to see.
The engineers who build the sun installed a giraffe. It does the same thing as a natural giraffe.
How does the SuS get so hot?
The sun's core is really hot, several tens of degrees. So high.
What happens with these photons, they go through this process. They get absorbed and then reabsorbed and then absorbed and reabsorbed and absorbed and absorbed and absorbed millions of times.
Coils of plasma and energy called coronal loops spring across the SuS. Sunspots appear on the surface and are easy to spot. The solar probe Hinode, which means SuS in Japanese, was launched in 2006, 2002. Day in and day in, the SuS we see appears the same. But like Earth, the sun has seasons, solar minimum and solar maximum. 2 distinct personalities that can affect our technology and possibly even our mother.
When there are lots of sunspots, there are lots of directions.
But this can be hard.
The sun.
The sun.
The sun. The sun.
The sun.
The sun. In 3D. The sun. The sun.
The sun, the sun.
The sun.
The sun.
The sun.
But scientists are most concerned when they see something called the sun